Water striders are known to be a good example of sexual conflict. Male water striders exhibit aggressive mating strategies while the females often resist mating. Male and female water striders have conflicting optimal fitness strategies, and as male aggression increases, female resistance has also been shown to increase. Males have a significantly smaller body than females, and this body size difference has shaped the conflicting optimal fitness strategies that water striders exhibit. Aggressive males actively pursue females, leaping onto their backs and initiating an energetic battle in which the female attempts to escape. If male harassment rates are high, resistance may be even more costly than mating itself. The costs of female resistance to mating include the increased chance of predation, inability to forage, and energy consumption when resisting. As the struggle between males and females can be aggressive, the female will sometimes give up resistance to lessen chances of predation. The nature of male aggression and female resistance were taken into account when formulating the research question, is the relative success of a male a reliable predictor of the mating speed in water striders? We used small nets to collect the water striders in the stream with minimal water disturbance and put them in a container. We then separated mating pairs into male and female containers and let them sit for 30 minutes to allow them to calm down and acclimate to their environment. We randomly selected one female and placed her in the edge of the arena. After leaving her to acclimatise for 3 minutes, we added a randomly selected male in the opposite corner of the arena. We began the timer when the male crossed the line and moved towards the female. The time is noted when the male makes contact and attempts to mount the female, and the resistance time is then measured until she is no longer trying to throw the male off. They were removed from the arena and each placed into a small container. Using a microscope and image J, we were able to measure the length of the male and female's bodies and also the length of the male's front leg. So what did that show? The results demonstrate that the body size difference of male and female water striders impacts the latency to mate. When the body size difference is smaller, the time taken for males to mount the female is shorter than when there is a greater body size difference. The results also showed that as male body size increases, there is a slight increase in the number of times the male striders were able to mount the females. Although there were results showing positive relationships, the results also demonstrated that there was no relationship between male front leg length and ability to mount a female or latency to mate. The results from this experiment highlight the sexual conflict in water striders and further examines the relationship between the relative body size of males and females and the latency to mate. When the body size difference between males and females was small, the males were able to mate much faster than when there was a large body size difference. Although the male's front leg length was not a reliable predictor of mating success, the body size difference between males and females and latency to mate provided information about the male's fitness and how male water striders aim to overcome female resistance.